Already we have seen errors in statics. If we wrongly say that there is a difference, we have type 1 error. If you wrongly say there is no difference, it is called a type 2 error. Setting alpha equal to 0.05 means that we accept 5% probability type 1 error. That is, we have 5% chance of rejecting a null hypothesis when we should fail to reject it. Levels of possibility of for type 2 errors are usually beta equal to 0.1, meaning that it has 10% probability of type 2 error, or 10% chance that is the null hypothesis will be false, but will fail to be rejected in the study. The reciprocal of type 2 error is power, defined as 1 minus beta, beta to be minus from 1, subtract from 1, and is the probability of rejecting the null hypothesis when you should reject it. Power of a test. The significance level alpha of a test shows how the testing method performs if repeated sampling. If H naught is true and alpha equal to 0.01, and you carry out test repeatedly with different samples of the same size, you reject the H naught type 1% of the time. Choosing alpha to be very small means that you reject H naught, even if your true value is different from H naught. The following four main factors affect power. Alpha level higher probability of type 1 error increase power. Difference in outcome between populations, greater difference increases power. Difference between outcome between populations, greater difference increases power. Variability, reduced variability increases power. Sample size, large sample size increases power. Large sample size increases power. How to have a higher how to have a higher power. The power is higher. The power is higher. The further the alternative values away from H naught. Higher significance level alpha gives higher power. Alpha gives higher power. Less variability gives high power. The larger the sample size, the greater is the power. Okay, the t-test, t-distribution. The t-distribution adjusts how good our estimate is by making intervals wider as sample size gets smaller. It converges to the normal confidence intervals when the sample size increases more than 30. T-distribution adjusts how good our estimate is making the intervals wide as sample size gets smaller. It converges to the normal confidence intervals when the sample size increases more than 30. The two main responses for using t-distribution to test differences its means. The two main reasons for using t-distribution to test differences means when working with a small samples from population that is normal, approximately normal, and when we do not know the standard deviation of a population, we need to use the standard deviation of the sample as a substitute for the population deviation. T distributions are continuous and symmetrical. T distributions are continuous and symmetrical and a bit fatter in the tails. Unlike the normal distribution, the shape of the T distribution depends on the degrees of freedom for sample. At smaller sample size, sample means fluctuate more around the population mean. For example, instead 95% values failing with 1.96 standard deviation of the mean at a sample size of 15 sample size in 15. They fall within 2.4 standard deviation. Okay. Confidence interval for t distributions. To construct interval x bar plus or minus t of a 1 minus alpha by 2 s divided by root n. That is number to use forming 95% confidence intervals. Normal distribution normal df of n minus 1 number to use normal t any n minus 1 3 6 10 15 20 30 40 50 59 80 100 200 500 number to use 1.96 times normal any 3.18 times 2.4 or 4.5 2.23 2.13 2.08 2.04 2.02 2.01 2 1.9 and 1.98 1.96 1.96 1.97 1.96 where x bar is the normal sample mean, n is the sample size s is the symbol standard deviation, t of 1 minus alpha by t is the critical value from the t distribution for n minus 1 degrees of freedom and the specified level of confidence we need, where x is the sample mean, n is the sample size, standard deviation, s is the sample standard deviation, deviation S is the sample standard deviation. T of 1 minus alpha by 2 is the critical value from the T distribution for n minus 1 degrees of freedom and the specified level confidence we need. The mean and the standard deviation of the mean. The mean and the standard deviation of the mean, the standard error, the sample size, the critical value from the t distribution for the desired confidence level. The critical value from the t distribution for the desired confidence level. Desired confidence level. The standard error is the estimate of how much the average sample means with fluctuate around the true population mean. The standard error is the estimate how much average sample means will fluctuate around the true population mean. First we didn't explain this one. This here S bar add or subtract with this t of alpha value we have to get, then divide by 2. It means it will take 0.5 percentage only. Then we have to rectify it, subtract minus with 1. Then how much we are getting, multiply with t. And here S is divided by root n, find root n, and it will be value reduced. Then divide, then multiply with this. Then if we want to add S bar minus subtract. Here also standard error equal to S divided by root n. The critical value is simply t equal to x bar minus mu divided by S by root n. That is t critical value simply x bar how much get, then say mu to be minus with this, then divide, then keep it that reading value, then root n small n divided by s divided by root n. Then how much you are getting, root example, then t got value. Where we need alpha level of significance usually 0.05 1 minus the confidence level and the degrees of freedom. The degree of freedom TF for this type of confidence level interval is sample size minus 1. For example, a sample size of 12 has the expectation that 90% of sample means will fall within 2.2 standard deviation of the population mean. We can also express this is a margin error 2.2 into S by root n. Here already we have seen S is the sample standard deviation. Sample standard deviation. As we know. And the confidence interval level is given as the twice the mg. T test assumptions of t test. Assumption of t test. The samples are unrelated or independent. Otherwise, the paired t test should be used. You can test for linear independence. The samples are unrelated. Independent. Otherwise, paired test should be used. You can test for linear independence. T test assume that the underlying population variances of two groups are equal. Variances are pooled